Hello, I'm Mikal from Balena, and in this video, I'm going to demonstrate how to set up Balena OS with secure boot and full disk encryption enabled inside a QEMU virtual machine. So let's get rolling. Here I'm starting with a pretty much empty installation of Debian 12, and the first thing that I need to do is to install Virt Manager and QEMU. On Debian specifically, the packages that I need are Virt Manager, libvirt daemon system, QEMU system x86, and OVMF. And of course, if you figure out the correct package names for your distribution, this should work the same way pretty much everywhere. With the packages installed, libvirt has created a new network bridge for the virtual machines to connect to by default. But as you can see, I do not have any extra network adapters available in my system. And that's because on Debian, this is disabled by default. So the first thing that I'm going to do is to launch Virt Manager, connect to the local libvirt, right-click the empty QEMU/KVM, then select Details, and on the Virtual Networks tab, select the default interface and start it with the little play button in the bottom. And I suppose I can also check Auto Start on Boot, just to be sure next time. And just like that, a new VirBR0 network adapter has appeared in the system and is ready to be used by our virtual machine. Next, I need the Balena OS image that I'm going to use for provisioning the virtual device. For that, I'll open a browser and navigate to Balena Cloud, where I've already created an account and logged in. I'll start by creating a fleet that my device will go to. I'll try to give it a descriptive name. And for the default device type, I'll select generic x86-64 GPT, as that's the only x86 device type that supports secure boot at this moment. With the fleet created, I can now add a device. And here all the default choices are reasonable, but in the bottom right corner, instead of flashing straight away, I'll use the down arrow to select Download Balena OS. And while it's running, I might as well look for the other thing that I need to download, which is the Balena CLI. So I'll open a new tab, navigate to github.com/balena-io/balena-cli. Here on the right, I'll go for the latest release, and because I'm running Debian on a laptop with an Intel CPU, I'll choose the Linux x64 variant. With both files downloaded, I can go to my Downloads directory, and I'll start by unpacking the Balena CLI. The binary I'm looking for is located in the newly created Balena directory under bin/Balena, so let's just try to run it as this and see if it works. And yes, that looks all right. That's a small help message, so we can move on. The first thing that I need is Balena login, and I do have multiple choices here, but I'll go with the recommended web authorization, which sends me to the browser where I'm already logged in, and therefore I can approve the CLI login from there. And it looks like it worked, so let's just try Balena fleet list to confirm that I can see the secure boot fleet that I've created a few moments ago. And there it is. That's great. So now I can proceed and unzip the Balena OS image that I've downloaded from Balena Cloud. And now that I have that, I can use the Balena CLI to configure the image and enable secure boot. This is necessary because secure boot is an opt-in feature, and the image as it is would not provision a secure boot enabled device by default. What I need to do is Balena OS configure --fleet secure boot. That's the fleet I want the device to go to. --version and the OS version, which in my case is 6.5.39. And then the most important bit, --secure boot, which actually triggers the secure boot opt-in. And of course, I also need to give it the image it should work with. It will ask about networking, but I think I'm fine with Ethernet for a virtual machine, so I'll just press enter, and just like that, the image is configured. Or well, it is configured to work with most hardware, but for QEMU specifically, we need one more trick. And for that, I'll need to set up a loopback device backed by the image, mount the first partition, and open a file called config.json. Here, inside the installer section, I need to create a new entry with key whitelist_PCR2 and value true. This is necessary because QEMU or OVMF behaves slightly out of spec here. It adds an OPROM to the virtual network card to enable PXE booting, but this OPROM with secure boot enabled should only be executed if it has a valid signature in the allowed database. But in reality, the OPROM will be executed unconditionally, whether it has a valid signature or not. And executing an unexpected OPROM would be evaluated as tampering by balenaOS, which means it would refuse to decrypt the disks, and in the end, the OS would not be bootable. But with the OPROM whitelisted, the image is now ready, so I can clean everything up and proceed to set up the virtual machine. Here in Virt Manager, I'll right-click the local QEMU/KVM and select New. I'll go for Manual Install, and for the operating system, I'll choose Generic Linux 2022. 2 CPUs and 4 gigs of memory seems fine, so I can just move forward. And a 25 GB hard drive is also fine. Here I'll tick Customize Configuration before install, and I'll try to give my virtual machine a somewhat descriptive name. Here on the hardware screen, we start with the firmware and chipset. The chipset we want to use is Q35, and just for completeness, the wrong option is i440FX. And for firmware, we want to go for UEFI, but there's multiple choices. So this one at the very bottom doesn't support Secure Boot at all. This one with MS does support Secure Boot, but has Microsoft keys pre-enrolled. And the one we're looking for is this one with .sucboot.fd, which does support Secure Boot and is in setup mode by default. I'll click Apply and move to the hard drive, which I'll switch from VirtIO to SATA. Again, Apply, and the next thing, I'll add a TPM. I'll make sure it's a TPM 2.0, and for the interface, we don't care, we support both TIS and CRB. And the last thing, I'll add a USB stick with my installer image. I've added a pool with my downloads directory off camera, so now I can just browse there and select the image I've configured a few moments ago. I'll make sure it's first in the boot order, and with that done, I'm ready to click Begin Installation. This is completely unattended. All you need to do is to wait for the virtual machine to shut down, which with the magic of filmmaking, I can make happen almost immediately. And with the machine powered off, all that remains is to remove the USB stick with the installer and start the newly provisioned device for the first time. After a few moments, the Balena logo should show up on the virtual display. And if I go to Balena Cloud dashboard, I should see a new device that appeared just now. And there it is. So I can SSH into it and check that it is indeed running with Secure Boot enabled and that the partitions are indeed encrypted with looks. And that is really all there is to it. I hope this was at least somewhat useful, and I hope you enjoy your newly provisioned Secure Boot enabled virtual machine.